This is an example of the central limit theorem for sample proportions. According to Pew Research, 28% of Americans use Instagram. Suppose a sample of 150 Americans is selected. Describe the sampling distribution for samples of size 150 drawn from the population. Use your distribution to complete this sentence. It would be surprising to find less than blank percent or more than blank percent of the sample used Instagram. The first thing we need to check is that we can apply the central limit theorem. In other words, we have to show that n times p and n times 1 minus p are both greater than 10. So n is our sample size, so n is 150. P is the population proportion, so p is equal to 0.28. So we have to show that 150 times 0.28 and 150 times 1 minus 0.28, which is 0.72, we have to show that both of these values are greater than or equal to 10. And you can either use a calculator or your good number sense, but both of those are greater than 10, which means we can apply the central limit theorem. Now, what does the central limit theorem say? The central limit theorem says that sample proportions will vary from sample to sample. If you take 150 Americans and ask them, do you use Instagram? One sample might have 28% say yes. One sample might have 31% say yes. Another sample might have 29% say yes. But what the central limit theorem assures us is that even though samples will vary, we know the behavior of those samples. The behavior of those samples is going to be that the distribution will be normal. It's going to be centered at the population proportion, which is 28%, and the spread of the distribution, which is called the standard error, can be computed using this formula, the square root of p times 1 minus p divided by n. So in our case, we have the square root of 0.28 times 0.72 divided by 150, which gives us a value of 0.037. So the center of the distribution is 0.28, and it has a spread of 0.037. And we know from our study of the normal distribution that any value that's more than 2 standard deviations above or 2 standard deviations below our mean is considered unusual. So to find these values, we would take 0.28 and add 2 standard errors. And then we would take 0.28 and subtract 2 standard errors, and that would give us the values beyond which we would say sample proportions were unusual. So on the high end, we would get 0.317 or 31.7%, and on the low end, we would get 0.243 or 24.3%. Let's take a look at another example. Use your sampling distribution to find the probability that, in a sample of 150 Americans, less than 25% use Instagram. So remember, we had a picture of the distribution. It's normal. It's centered at 0.28, and the spread of the distribution is 0.037. And what we're being asked to find is the probability of a sample proportion less than 25%. In other words, we're looking for the area in this left tail of the distribution. And we're going to find that using a normal calculator. In StatCrunch, we're going to go to StatCrunch, and we're going to find our calculators. And we're going to pick the normal calculator because we're working with the normal distribution. We're going to enter in the center, we're going to enter in the spread, and then we're going to look for this area using the calculator. So let's navigate over to StatCrunch. So in StatCrunch, let's start with the beginning. So we would come here to Stat, Calculators. We're going to look for the normal calculator. We're going to put in the center, and the center of our picture is 0.28. We're going to put in the spread of our picture, which is 0.037. And the value we're looking for are values which are less than 0.25. Oops. I have to change my mean here. I think I didn't see the decimal point. So 0.28, a standard deviation of 0.037, and we're looking for values that are less than 0.25. Good. So now we'll compute, and we have an answer of 0.209, or 20.9%. So in StatCrunch, we found out the area to the left using this picture of a center of 0.28 and a spread of 0.037. We just found out that this area here, less than 0.25, has a value of about 20.9%. And that's how you use the central limit theorem for sample proportions.